Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0171, which stands for Fuel System Too Lean, specifically for the 2011 to 2016 Honda CRV. This diagnostic trouble code indicates a problem related to a lean fuel mixture being delivered to the engine. A lean condition typically means there is not enough fuel in the air-fuel mixture necessary for optimal combustion. Key components involved in this issue include the mass airflow MAF sensor, which measures the amount of air entering the engine, and various sensors that help manage fuel delivery. The MAF sensor is usually located in the intake air duct before it enters the engine, while other sensors, such as the AF, air fuel sensor, and fuel injectors also play critical roles in ensuring that the engine runs smoothly and efficiently. This guide will help you to diagnose and repair the issue accurately while avoiding unnecessary steps. The diagnostic code P0171 indicates a lean fuel condition in the engine, meaning the air-fuel mixture is off balance, specifically with too much air present compared to fuel. Primary components at risk include the MAF sensor, which is crucial for measuring air intake, as well as the AF sensor that monitors the efficiency of the combustion process. The MAF sensor is generally located within the intake duct after the air filter, responsible for sending vital data to the powertrain control module, PCM. The PCM uses this data to adjust fuel delivery. If these sensors malfunction, or if there's a leak in the fuel system, it can lead to poor engine performance or increased emissions, making timely diagnostics essential. Several possible causes could trigger DTC P0171, indicating a lean fuel condition. The MAF sensor may have accumulated dirt or debris, affecting its ability to accurately measure air intake. Additionally, issues with fuel injectors that may not be delivering adequate fuel can contribute to this problem. Vacuum leaks in the intake system can also create an imbalance, allowing excess air into the engine. Another common cause is the malfunctioning of sensors such as the AF sensor and other related components. Each of these factors needs to be systematically checked to identify and resolve the root issue efficiently. The symptoms associated with DTC P0171 can manifest in various ways. Drivers may notice a rough idle, where the engine struggles to maintain smooth operation. This could lead to a noticeable reduction in fuel efficiency as the engine compensates for the lean condition. Additionally, increased emissions may occur because an improper air-fuel mixture can lead to unburned fuel being expelled from the exhaust system. Any of these symptoms should prompt a detailed diagnosis to avoid further complications and to restore the vehicle's performance and compliance with emission standards. The first step in troubleshooting DTC P0171 involves problem verification. Start by letting the engine idle in either the park or neutral position without any additional load. Using a diagnostic tool, check the AFFB, short-term fuel trim parameter. If this value exceeds 1.33, it indicates that the fuel trim is out of range, pointing to a lean condition that needs deeper investigation. If the reading is okay, move to the next step. It's crucial to ensure that the measurements are taken accurately, as they guide your subsequent actions in this diagnostic process. In the second troubleshooting step, review the onboard snapshot captured when the AFFB was at its highest value. Record important parameters such as engine speed, vehicle speed, relative throttle position TP sensor, and accelerator position APP sensor values. It's advisable to drive under previously determined conditions while monitoring these parameters. Analyzing data while in motion helps confirm whether the AFFB remains consistent with previous snapshots. Accurate readings during this phase will validate whether the issue persists and guide further intervention. The third troubleshooting step involves checking the MAF sensor for any debris that could obstruct its function. To do this, carefully remove the MAF IAT sensor and inspect it for dirt, bugs, or foreign objects. If you find any debris, it's essential to remove it and clean the sensor area to ensure accurate air measurement. After this, utilize a vacuum cleaner to clear out debris from the air cleaner housing to maintain an unobstructed airflow. If no debris is found, simply reinstall the MAF sensor and proceed to the next troubleshooting step. For the fourth step, conduct a visual inspection of critical components such as the crankcase breather hose, air cleaner housing, oil cap, and dipstick. Look for any disconnected hoses, cracks, or signs of damage that may lead to air leaks, which would further contribute to the lean condition. Identifying any issues at this stage can prevent unnecessary replacements in subsequent steps. If damage or disconnections are discovered, repairs should be executed immediately. And then you can carry on to the next troubleshooting step. The fifth troubleshooting step requires you to let the engine idle while pinching the vacuum hose connected to the brake booster. This action helps identify whether there are leaks present in the brake booster or hoses. While the hose is pinched, check the AF/FB parameter using the diagnostic tool. If the parameter exceeds 1.33, it suggests that the brake booster is not leaking, and you can proceed to the next step. However, if you notice a drop in the AF/FB, this could indicate a vacuum leak, prompting further checks on the brake booster system. Continuing with step 6, let the engine idle and pinch the PCV, positive crankcase ventilation vacuum hose. This test aims to verify the integrity of the PCV system. After you pinch the hose, check the AF/FB parameter again using the diagnostic tool. If this value exceeds 1.33, it indicates no leakage from the PCV system, allowing you to move to the next step. However, a drop in AF/FB suggests a leak, requiring you to investigate the vacuum hoses for any issues. This careful checking helps isolate the source of the lean condition in the fuel system. For the seventh step, start the engine and hold it at 3,000 RPM until the radiator fan activates. It's crucial that the engine coolant temperature (ECT) sensor reads above 158 degrees Fahrenheit, 70 degrees Celsius during this check. With the vehicle in park or neutral and all electrical loads turned off, you will then monitor the MAF sensor reading. Hold the accelerator steady at 2,500 RPM while using the diagnostic scanner to analyze the values. Verify that the MAF sensor reads between 7.0 and 8.6 grams per second, G per second. If readings are within range, the MAF sensor is functioning correctly, prompting the need for additional checks in case of irregular readings. In the eighth troubleshooting step, it's crucial to check fuel pressure under conditions when the AF/FB parameter is 1.33 or higher. Verify that the fuel pressure falls within the range of 330 to 380 kilopascals, or roughly 48 to 55 psi. If the fuel pressure is adequate, you can move on to step 9. However, a pressure reading outside this range indicates a problem with fuel delivery, necessitating the replacement of the fuel tank unit. Maintaining appropriate fuel pressure is vital for achieving the right air-fuel ratio essential for an efficient engine operation. During step 9, start by disconnecting the intake air duct from the air cleaner housing. Utilize an OTC LeakMaster Evaporative Emissions System Tester Kit to insert a large intake manifold adapter cone into the intake duct. This step involves directing smoke into the intake manifold to check for any vacuum leaks. Carefully inspect critical areas, including the intake manifold and gaskets, throttle body, air intake ducts, and all associated vacuum hoses for leaks. Identifying any leaks is essential, as they can significantly affect engine performance. If leaks are found, they must be repaired before advancing to the final steps. In the 10th troubleshooting step, you'll replace the fuel injectors with known good injectors. Once this is completed, operate the vehicle under the same conditions where AFFB was measured at 1.33 or more. As the engine operates, check the AFFB parameter again to see if it still exceeds the threshold. If it does, the injectors are likely not the source of the issue, allowing you to proceed with the next step. Alternatively, if the reading drops back to normal, this indicates that the original injectors were indeed the cause of the lean condition, and they should be replaced. Step 11 involves replacing the A fuel sensor, specifically sensor number 1, with a known good unit. After replacing, operate the vehicle under the same driving conditions that previously exhibited a high AFV. Using the diagnostic tool, re-evaluate the AFV parameter once more. If the readings still exceed the threshold, the AF sensor is likely not the root cause of the issue. However, if the values return to normal, this indicates replacement rectified the lean condition, highlighting the importance of this component in the fuel management system. The 12th step entails addressing potential fuel quality issues. If the vehicle experiences misfires shortly after refueling, there may be a fuel-related problem. Begin by draining the fuel tank entirely and refilling it with known good fuel to ensure quality. Operate the vehicle under prior conditions where the AFFB was more than 1.33. Following these adjustments, check the AFFB parameter again. If it remains high, it suggests that the fuel was contributing to the lean condition, warranting additional investigation into the fuel delivery system or possibly replacing the powertrain control module, PCM, should the issue persist. For final repair verification, turn the ignition switch to the on position and reset the powertrain control module, PCM, using the diagnostic tool. Following the reset, conduct the idle learn procedure, which is essential for the PCM to adjust its parameters based on the recent repairs. Start the engine and hold it at 3,000 RPM without load until the radiator fan activates. Allow the vehicle to idle, then operate it under the same conditions where AFEB was initially elevated. Continuously monitor the AFEB parameter to ensure it remains within normal ranges. Confirming the successful resolution validates that the troubleshooting steps effectively addressed the P0171 issue. To prevent a recurrence of DTC P0171, performing regular preventive maintenance is key. Begin by ensuring that air filters remain clean, as clogged filters can hinder airflow, affecting the MAF sensor readings. Regularly inspect the MAF sensor for cleanliness, as dirt buildup can lead to false readings and potential lean conditions. Furthermore, periodically check all vacuum hoses for signs of wear and tear or possible leaks. Implementing these routine checks and maintenance will help to ensure the vehicle's air-fuel system operates optimally, minimizing the chances of future issues. In conclusion, understanding DTC P0171, which indicates a lean fuel system condition, is vital for effective troubleshooting and repair. Key components such as the MAF and AF sensors play an essential role in regulating the air-fuel ratio, and any failure or obstruction can lead to serious performance issues. Following the detailed troubleshooting steps ensures a systematic approach to diagnosing this problem. From checking airflow to verifying fuel quality, each step is designed to isolate and address the specific issue causing the lean condition. Adhering to preventive maintenance will help keep your vehicle functioning smoothly for years to come. Please like and subscribe to the channel. See you next time.